Hi everybody, in this video I'm going to be going over the review sheet for test number 2. So in question number 1 it says, in the accompanying diagram of right triangle ABC, and we're given side measurements, and we need the tangent of angle C. So if you write down so, ka, toa on your paper, tangent is T, so that tells us that the tangent ratio is opposite over adjacent. I'm going to write that over here. Tangent of angle C is opposite over adjacent. So our tangent ratio, focusing on angle C, would be opposite, which is 8, over adjacent, which is 15. And that's answer choice number 1. Number 2 says, in the diagram below of right triangle JTM, JT is 12, JM is 6, and angle JMT is a 90-degree angle. And it says, what is the value of cotangent of angle J? So I know that cotangent is the reciprocal of tangent. So first I need to find tangent, and then I can take the reciprocal of tangent to get cotangent. So we're focusing on angle J. And for tangent, once again, I need opposite over adjacent. But right now, I don't have the side opposite from angle J. That's empty. We don't have a measurement. We have 2 other sides of the right triangle, so we can find the missing side using the Pythagorean theorem. I'm going to plug in to a squared plus b squared is equal to c squared. One of our legs is 6. We're finding the other leg, and we know that our hypotenuse is 12. So we have 36 plus b squared is equal to 144. Subtracting 36 from both sides, we have b squared is equal to 108. Taking the square root of both sides to get b by itself, we have b equals to radical 108. To put this into simplest form, because right now this doesn't look like any of the answer choices here, I'm going to break down the square root of 108 into the largest perfect square that goes into it evenly, and that would be 36. And 36 goes into 108 3 times. Radical 36 is 6. Radical 3 doesn't break down any further. So what we have right now is side MT from doing the Pythagorean theorem. So all we need to do now is find our tangent ratio and then flip it. So tangent is opposite over adjacent. So opposite from angle J, and I'll write this over here. I'm running out of space. Tangent of angle J. So opposite from angle J is 6 radical 3. And adjacent is 6. So all we have to do to get cotangent of angle J is flip this. So when I flip it, I have that cotangent of angle J, which is the reciprocal of tangent, is 6 over 6 radical 3. Now we don't leave radicals in the denominator, so we're going to rationalize it by dividing the bottom and the top, multiplying the bottom and the top by the radical we want to get rid of, which is radical 3. So in the denominator, I have 6 times 3, which is 18. And in the numerator, I have 6 radical 3. 6 and 18 divide evenly into each other. It cancels out from the top, and we have 3 left in the denominator. So that is radical 3 over 3. You can also think of this as being 1/3 radical 3, which is the same thing as radical 3 over 3. You can imagine that there's an invisible 1 in front. So that's answer choice number 1. In number 3, it's asking us what ratio is always equivalent to sine of angle A. And in the givens, they tell us that BC is parallel to DE. So just keep in mind here that we have 2 similar triangles. The small and the big triangles are similar. They share an angle. And since we have parallel lines, corresponding angles are also congruent. So just keep in mind that we have similar triangles. The reason that that's going to be important is because since corresponding sides of similar triangles are proportional, when we take the sine of angle A, that's equivalent to opposite over hypotenuse for the small triangle, and also opposite over hypotenuse for the big triangle because the sides are proportional. So remember that sine is opposite over hypotenuse, and we're focusing on angle A. So let's go through each answer choice and see which one correctly represents opposite over hypotenuse. AD. Already looking, AD is not opposite from angle A. AD is the hypotenuse of the big right triangle, so already that one's not correct. AE. AE is not opposite from angle A. Opposite from angle A would be over here. This is adjacent to angle A. It's the adjacent leg from the big triangle, so already that one's wrong. BC. BC is opposite from angle A. Let's see if it's over hypotenuse. AB is the hypotenuse of the small triangle. Wonderful. So we have opposite from the small triangle over hypotenuse from the small triangle. So that is a correct sign ratio. Why number 4 is wrong? Once again, AB is not opposite from angle A. AB is the hypotenuse of the small triangle, but for sine we need opposite over hypotenuse. In a right triangle, sine of 40 minus x equals cosine of 3x. What's the value of x? Remember that sine and cosine are cofunctions, which means that they are equal when their angles add up to 90 degrees. So we can make an equation where we take the angle from sine, which is 40 minus x, and we take the angle from cosine, which is 3x, and we equal them to 90 degrees. Combining our like terms, we have 40 plus 2x is equal to 90. Subtracting 40 from both sides, we have 2x is equal to 50. And then dividing both sides by 2, we have x is equal to 25. And the question was just asking for the x value. It wasn't asking us to plug in for any of the angles. The accompanying diagram shows 2 cables of equal length supporting a pole. Both cables are 14 meters long, and they are anchored to points in the ground 14 meters apart. So I see that we're working with an equilateral triangle over here. So not only do we know that equilateral triangles have 3 equal sides, we also know that the angles are equal, and they all are equal to 60 degrees. So we have 60, 60, and this whole angle is 60 at the top. And it's being broken in half because we do have an equilateral triangle. So that's 30 and 30. So we have a 30, 60, 90 triangle. And we're trying to find the height of the pole. So I'm going to label that as x. Remember, 30, 60, 90 triangles have sides in the ratio of 1 to radical 3 to 2. That's the special ratio that the sides of 30, 60, 90 triangles are always in. So we were given the 14. We can focus on any of the 30, 60, 90 triangles, this one or that one. They're both exactly the same. So I'll just focus on this one so we can get a better look at it. Oops, I made that line pretty horribly. Okay, so we're given the 14. The 14 is across from the 90-degree angle. So that means it's the biggest side because it's across from the biggest angle. So that's the 2 part of the ratio. We need to find x, the height, which is across from the 60-degree angle. So it's the middle biggest part of the ratio. It's the radical 3 part. So if I can take the largest side and use it to get the smallest side, then I can easily get from the smallest side to the middle biggest side, which is what I want. So we know that to get from the smallest side to the biggest side, we multiply by 2. So to get from the biggest side to the smallest side, we do the opposite and we divide by 2. So taking the biggest side, 14, we divide by 2. 7 is the smallest side. So that's across from the smallest angle, the 30-degree angle. Now all we need to do is go from the smallest side to the middle biggest side. And we know to go from the smallest side to the middle biggest side, we multiply by radical 3. So the middle biggest side, which is the height that we're looking for, would be the smallest side times radical 3, which would be 7 radical 3. And there we have it, 7 radical 3 meters. That's the exact height of the pole. In right triangle ABC, so I don't see a diagram, so I'm going to start setting mine up. Here's my right triangle. Angle C is 90 degrees. Side A is 4. That's opposite angle A. And sine of angle A is 1/2. What is the length of the hypotenuse? So sine is the so part of SOHCAHTOA. It's opposite over hypotenuse. So we need a hypotenuse that's going to make sine of angle A 1/2. Focusing on angle A, like it says, we already have opposite for opposite over hypotenuse. Opposite is already 4. So we need to think about which one of these answer choices or the denominator would make the fraction 1/2. And the answer is 3. If I put 8 for the hypotenuse, that reduces to 1/2. So sine of angle A would be 1/2 if this is 4 and this is 8. If angles A and B are complementary, then secant of B equals 2. Well, remember that secant and cosecant are cofunctions. So that means they are equal when their angles add to 90 degrees. So the correct answer choice would be number 1, because what number 1 is saying is that we can find the angle of secant if we take the angle of cosecant and we do 90 minus that angle. For example, let's say that cosecant was 50 degrees, and we wanted to find what secant would be, what the angle for secant would be. We can substitute in 90 minus 50, and that would give us 40, which is the angle that we need. If you try to substitute in examples with the other 3, you'll see that it doesn't work out to give you the complementary angles. Number 1 is the definition of a function. If 2 trig functions are cofunctions, then if you start with the angle from one of them, you can find the angle of the other by doing 90 minus that angle to find out what's going to be complementary with it. The center pole of a tent is 8 feet long, and the side of the tent is 12 feet long. If a right angle is formed where the center pole meets the ground, what is the measurement of angle A to the nearest degree? So we're looking for angle A. We do have a right triangle, and I see that we have information about the side opposite from angle A and about the hypotenuse of the right triangle. So in SOHCAHTOA, that would be sine, because we have opposite and we have the hypotenuse. So we can set up a sine ratio. Sine of angle A is equal to opposite, which is 8, over hypotenuse, which is 12. We need to figure out what angle A is, and notice how it's trapped inside the sine function. So in order to get it out, we need to undo sine, and we do that with inverse trig. Think anytime you're solving for an angle, inverse trig is how you're going to solve. So we do sine inverse of 8 over 12 is equal to angle A. And if you type this into your calculator, I get approximately 42 degrees. Number 9 says a diagonal of a square measures 18 centimeters. Find the perimeter of the square in simplest radical form. So here's my square, and I know that the diagonal of the square is 18 centimeters. Remember that squares have all 90-degree angles, and the diagonals bisect the angles because squares have all the properties of a rhombus. So this 90-degree angle is being split equally in half because we do have a square. This 90-degree angle is being split equally in half because we do have a square. So what we have here are two 45, 45, 90 triangles. So since squares have all equal side lengths, if we can find one side length, then we know what they all are and we can find the perimeter. So I'm going to focus on one of these 45, 45, 90 triangles. They're both exactly the same. So I'll focus on this one because it's closer to where my pen is. And we have 18, which is across from the 90-degree angle. So that is the hypotenuse It's across from the largest angle, so it's the largest side of the 45, 45, 90 triangle. Remember, all the sides of a 45, 45, 90 triangle are in the ratio 1 to 1 to radical 2. So this 18, since it's the biggest side, is the radical 2 part of the ratio. To go backwards and get one of the legs, since they're equal to each other, all we need to do is divide by radical 2. So I'm going to take 18, and I'm going to divide it by radical 2. Now, we don't leave radicals in the denominator, so we're going to rationalize the denominator by multiplying the bottom and the top by radical 2. So here we have 18 radical 2 over 2. 2 goes into 18 evenly, so that is 9 radical 2. So we just found that each side of the square is 9 radical 2. Since squares have 4 equal sides, the perimeter means adding up all of the side lengths. So if I add up 9 radical 2 plus 9 radical 2 plus 9 radical 2 plus 9 radical 2, they're like terms because they all have radical 2, so we can add the coefficients. 9, 18, 27, 36. I get 36 radical 2 as my perimeter, and I could put centimeters. That's what units here. A 20-foot support post leans against a wall. So here's my wall. I'll make my support post leaning against the wall. And I know the support post is 20 feet. And it makes a 70-degree angle with the ground. So here's the ground. So the post and the ground make a 70-degree angle together. To the nearest tenth of a foot, how far up the wall will the support post reach? So we need to find how far up the wall the post is. So that represents this side over here. I'm going to call that X. So it's a real world situation. So we have a 90-degree angle. If we have a wall and a ground, they are perpendicular to each other. We can focus on the 70-degree angle. We're finding opposite, and we have hypotenuse. So that tells me we're going to be using sine because sine is opposite over hypotenuse. So let me write down sine of 70 degrees is equal to x over 20. From here, we can put this over 1 so that we can cross multiply. We have 20 sine of 70 is equal to x. And if you type 20 sine 70 into your calculator and you round to the nearest tenth, like the question says, I got approximately 18.8 feet. In triangle ABC, measure of angle C is 30, and side A is 8. If the area of the triangle is 12, what is the length of side B? So we need to find this side over here. Side B is across from angle B. So they give us area. So we know that our new area of a triangle formula for area of a triangle using trig is area equals to 1/2 BC sine of angle C. Remember, in this area formula, B and C just represent two sides next to each other, and angle C is the angle in between those two sides. So here we have one side, and we're finding the side next to it, and we do have the angle in between the two sides that we're looking at. We know that the area is 30, so is 12. So I'm going to plug in 12 for area, and that's equal to 1/2. One of our sides is 8. The other side is the side that we're finding. I can leave that as B or C or X, it doesn't matter. And then sine of the angle in between the two sides, which would be 30 degrees. Okay, so let me just simplify this a bit. 1/2 times 8 is 4. So we have 4 x sine 30. Let me divide by 4 on both sides. 12 divided by 4 is 3. And now to get the x by itself, I'm going to divide both sides by sine of 30. So I have x is equal to 3 divided by sine of 30. When I put that into my calculator, I get that x is equal to 6. So that's the side that we're looking for. And if you wanted to confirm that your answer was correct, you can plug both of these sides and the angle back into your area of a triangle formula and see that you do get 12. The top of a lighthouse T is 215 feet above sea level. The angle of depression from the top of the lighthouse to the boat is 26 degrees. Determine to the nearest foot the horizontal distance from the boat to the base of the lighthouse. Oops, oh no. There we go. So we know that the angle of depression and the angle of elevation are congruent because they are alternate interior angles. Remember, we have that backward Z or that forward-facing Z. So alternate interior angles are in the corner of the letter Z. So we do have congruent alternate interior angles. So now we can focus on the 26-degree angle. And we know that the 26-degree angle, from that, the 215 is opposite. And x is the adjacent side. So that tells me we're going to be using tangent because tangent is opposite over adjacent. So tangent of 26 is equal to 215 over x. Cross multiplying, we have x tangent of 26 is equal to 215. To get the x by itself, we can divide both sides by tangent of 26. So I have x is equal to 215 over tangent of 26. So we have x is approximately, if you type this into your calculator, it does say to round to the nearest foot. So x is approximately 441 feet. The accompanying diagram shows a flagpole that stands on level ground. Two cables, R and S, are attached to the pole at a point 16 feet above the ground. The combined length of the two cables is 50 feet. If cable R is attached to the ground 12 feet from the base of the pole, what is the measure of the angle x that cable S makes with the ground? So the first thing I notice is that I have more information about this right triangle on the right than this right triangle on the left. I have two sides. I have 16 and 12. So I can find the third side of this right triangle using the Pythagorean Theorem. So I'm going to do that up here. A squared plus b squared is equal to c squared. One of the legs is 16. The other leg is 12. And we don't know what the hypotenuse is. That's r. (16 squared plus 12 squared, if you do that on your calculator, is 400. So we have 400 is equal to c squared. So c is equal to radical 400. Radical 400 is a perfect square, and it's 20. So I know that r, the last side of the right triangle over here on the right, is 20. In the question, they told us that the combined length of the two cables is 50 feet. So if one of the cables is 20, then the other cable S needs to be 30 to make that combined length of 50 feet. And now that we know that this is 30 over here, we can easily figure out what angle x is. We can focus on sorry, my highlighting is awful here. So we can focus on the right triangle on the left because we know it's a right triangle. That's where angle x is located. And we have two sides of that triangle. We have the side opposite, which is 16, and we have the hypotenuse, which is 30. So that tells me we're going to be using sine. So sine of angle x is 16 over 30. So to find the angle, remember, I'm going to solve using inverse sine. So if we take inverse sine of the sine ratio, that gives me the angle that made that ratio. And if you put this into your calculator, it's approximately 32.23095. So it's approximately 32 degrees, because it does say the round to the nearest degree in the question. Diego needs to install a support beam to hold up his new birdhouse. The base of the birdhouse is 24.5 inches long. I don't know about you guys, but I would prefer to write this as 24.5, which is the same thing as 24.5. The support beam will form an angle of 38 degrees with the vertical post. Determine and state the approximate length of the support beam x to the nearest inch. This one, I think the diagram is just confusing, but really, we just have a right triangle. We have a focus angle in the right triangle, the 38-degree angle. We know the side opposite from the 38-degree angle, and we know the hypotenuse of the right triangle. So once again, this comes down to sine because we have opposite and we're finding hypotenuse. So we can set up our sine ratio because we do have a right triangle. Sine of the 38-degree angle is 24.5 over x, which is the hypotenuse. Cross multiplying, let me stick this over 1 so we can have a proportion. Cross multiplying, we get x sine 38 is equal to 24.5. Dividing both sides by sine of 38, we have x is equal to 24.5 over sine of 38. If you enter this fraction into your calculator, we get x is approximately 40 inches because it does say to round to the nearest inch. You are a block away from a skyscraper that is 780 feet tall. Your friend is between the skyscraper and yourself. The angle of elevation from your position to the top of the skyscraper is 42 degrees, and the angle of elevation from your friend's position to the top of the skyscraper is 71 degrees. To the nearest foot, how far are you from your friend? So ultimately, we're finding from you to your friend, so I'm just going to put that as a question mark because that's ultimately what we're finding. I don't think I have enough information to find that right away because the triangle that distance is a side of is this non-right triangle over here. But in that triangle, I can find the angles because I have this angle, I could find this one and that one, but I don't have any sides. So I'm not going to be able to set up a law of sine equation there. I would need at least one side in order to do that. So instead, why don't we focus on the right triangles? Since this is a 90-degree angle because the ground and towers are perpendicular, it's a real world situation, we have two right triangles. We have the small right triangle. Oops, my mistake there. I just circled the one that's not a right triangle. So we have the small right triangle over here. No, that's the 90-degree angle. And we also have the big right triangle. So I'm going to start with the big right triangle. In the big right triangle, I have the 42-degree angle. And I know the side opposite from that angle is 780. I need to find information about this side. So it would be probably useful to me to find information about the adjacent leg of the big triangle. If I can get this whole adjacent leg of the big triangle, and I can get this part of the small triangle and subtract, then I can figure out this distance over here. So that tells me I'm going to be using tangent. So let me set up a tangent ratio. Equal to opposite, which is 780, over adjacent, which we don't know what it is, so I'll call it x. And just to make this a little bit more clear, I'm going to label this as x so that we can keep in mind that this is what we're solving for when we found x. I'm going to put this 1 and cross tangent 42 equals 780. Dividing by 2, we have 780 over tangent. I'm not going to round yet because I don't want to round it to my very last step, because otherwise you might make a rounding error and get a point deducted from your question, and you don't want that to happen when you know what to do. Next, I'm going to focus on the small right triangle. So in the small right triangle, once again, we have a focus angle at 71, and we know opposite. Opposite from the 71-degree angle is once again the 780-foot distance. That's the opposite side. It would help us out to get the adjacent side, because if we get the adjacent side and we already have this side, x, we can subtract off the smaller part and be left over with what we need. So I'm going to label this part y. And once again, we can set up a tangent ratio, opposite over adjacent, to find the adjacent side. So I'm going to do that over here. Tangent of 71 degrees equals to opposite 780 over y. I'm going to put this over 1 so we can cross multiply. Y tangent of 71 is equal to 780. Dividing by tangent of 71 on both sides, I have y is equal to 780 over tangent of 71. Since I have x and I have y, I can subtract to find the distance from you and your friend, which is what I need. So I'm going to do the bigger side, which is x, minus the smaller part, which is y. And that should give me the distance that we need. So in my calculator, I can do x, which is 780 over tangent of 42, minus y, which is 780 over tangent of 71. And if you enter that into your calculator and hit enter, we get 597.70222320008, and that rounds to approximately 598 feet, because the question does say to round to the nearest foot. One more thing to keep in mind, and it's not a question that's on the review sheet, but it's something that's going to come up on the test. We talked about area of a triangle, but it also applies to parallelograms, because when you have a parallelogram, if you draw in a diagonal, can be separated into two smaller congruent triangles. So, for example, if I knew that this side was 10, this side was 20, and the angle in between was like 50, since we have a parallelogram, the side opposite is also 10, the side opposite here is also 20, and the angle opposite is also 50. So I could find the area of this triangle using the formula area equals to 1/2 AB sine of angle C. I would just plug in two sides next to each other, which are 10 and 20. And sine of the angle in between those sides, 50, is the angle in between these sides. And I would see what this is. Since this triangle is exactly the same, I could just multiply our area for one triangle by 2. Or you could repeat the process, find the area again, even though it will be exactly the same, but for the other triangle, it's going to be the same because they're congruent triangles. And then you can add the two areas together. So I just wanted to throw that out there so that you guys keep that in mind.